in the Department of Engineering at National Institute of Technology, Trichy. Dr. Saravanan is a renowned academician and researcher with more than 15 to 20 years of experience in water resources engineering, hydrology, remote sensing and GIS, climate change studies, and disaster modeling. He has completed his PhD from IIT Roorkee and has an impressive research record over 80 publications in reputed international journals. And he has also authored several book chapters, which is published by leading global publishers. He has guided many PhD scholars and postgraduate scholars, coordinated AICTE, GYAN, and DSC sponsored FDPs and workshops, and served as a reviewer for several high impact international journals. His contributions have been widely recognized, including the Jal Vignan Purashkar, the Best Performer Award at NIT Trichy, and being listed among the top 2% scientists globally by the Stanford University elsewhere. With his vast experience and global exposure, we are confident that today's session will be highly insightful and enriching. Now, I now invite Dr. Saravanan to kindly take over the session. Welcome, sir.
Thanks, Professor Gauri, for the introduction. Good evening, participant. Thanks for the session. My health is a little bit not good and my throat also not fine. So kindly adjust the thing. So today I am going to present my topic on geospatial approach to urban flood management using the machine learning and MCDM model. So normally flood means it's a excessive flood or excessive water overflowing
Good
the
evening.
backfill storage.
Your screen is not been shared, sir.
Oh, sorry. Is it fine now?
No, sir. Earlier it was visible, sir, but now it is.
I will completely reload this once again.
Okay.
Yes.
Is it fine?
Yes, sir.
Yes, sir. Now it is visible.
So flood means normally it is a bankfull discharge overflowing the river when its capacity exceeding the flood carrying level. So normally flood is a most devastating and widespread, frequently occurring natural hazard in the world.
Sir, excuse me, sir. PPT is not visible right now. PPT is not.
Okay. So because I am using two screens, I don't know which screen is shared this one.
Sir, we are now viewing your face. Your front camera has been enabled, so that screen we are able to view.
Okay. So allow me a few minutes.
Currently, you are looking on monitor now, sir. That screen is visible.
Yeah. But the problem is because of the two screen, it's displaying in both screen.
Professor, can you send the PPT? I'll try to share the PPT.
The size is
that
very
is the
big.
case, then sir unable to move front and back now.
Okay, one sec. Just allow me one sec.
Yes, sir.
Sure.
Select Windows or screen. Okay. So just now I made duplicate. Now it will be visible, I guess.
Yes, sir. It's visible, sir.
Okay. Is it visible now?
Yes, sir. It's visible, sir.
Yes, sir.
Okay, thank you very much. So normally the flood is most frequently occurring phenomena in our country, not only in our country, throughout the world. Because of the climate change and other phenomena, the flood pattern and flood frequency is completely changing everywhere. Even some of the desertic country nowadays, they are getting high flood and high intensity flood. So the flood, study of flood is highly important for the best social and economic analysis. If you consider this report from 2000, 37% of Asian population living in the cities and its proportion projected to the flood by the 2025 in 50%. That means each and every cities they are having the flood frequency and the flood intensity is increasing. For example, if you are considering our Chennai city in 2015, we are facing a very big flood event. It is not due to the cyclonic storm movement, but even for the local tropical depression itself, we are facing a very big flood inundation problem, consecutively at 2 times. So similarly, our Mumbai, Bangalore, Hyderabad, all the cities, they are frequently getting flood inundated because of the urbanization and climate change patterns. So, so this pattern will increase each and every years for the next forthcoming periods. What is the problem in that flood? Flood occur due to the heavy rainfall happening in a shorter period, as well as it's happening because of the snow melt, deforestation, urbanization, and glacier lake outburst. Recently, if we see in our Himachal Pradesh, because of the heavy downpour happened in that Chorabari glaciers, it is in Uttarakhand. Because of that, there was a very big glacier lake outburst flood happened. Like that in 2025 also in Uttarakhand region, another one flood event happened. So nowadays, very high and shorter duration rainfall will induce the flood and debris flow in the hilly regions. So what is the problem due to the flood means? If the flood happens in urban or in flat terrain areas, it will inundate, it will spoil the building, vegetation, and other properties in the particular area. If the same flood with a high intensity, if it is happening in the hilly region, it will induce landslide and debris flows. Recently, in 2018, we seen that the entire Kerala was affected by so many landslide incidents. Not only Kerala, even in the adjacent state, Karnataka also faced a severe landslide problem in 2018. After that, 2019, 20, 25 also, there was a major flood events happening in that one. Okay, so if you see that scenario in global scale, there are many countries, even in dry countries, that is very less rainfall countries, also faced a flood problem. In 2000, this picture I will show you the major flood event happened in 2022 and 23. So in 2022 January, sorry, in 2022 June, there was a heavy flood happen in West Bengal, Assam, and Bihar region. Similarly, in 2022 same July time, German, Belgium, Netherlands was affected by severe flood. Similarly, in China, the historical rainfall was happened in July 2022 and causes more than 1 million people affected by that flood. Similar time in August 2022, Pakistan was affected by a very big flood event. Even in that satellite picture, you can see that the inundated area. Similarly, in Australia, China, Mexico, then Thailand. Recent year, last year also, Thailand was severely affected by the flood event. And US, every year, US is affected by flood due to the tropical storm. In Chile also, this time severely affected by the flood event. And the very big flood even happened, if you see, it's happened in September 2022 in 3 countries, Libya, Algeria, and nearby Turkey region. So in that one, you can see that picture before and after the flood event. So normally the Libya was a desertic country. There was a very less rainfall region. But because of the storm movement and heavy rainfall happened in that coastal city, it was generated a very big flash flood, and it devastated so many buildings and urban infrastructure. Similarly, in North India, if you see, in that 2023 time, it was a heavy rainfall. It made lot of landslide and other thing. Even even it's spoiled a railway line and station inundated by the flood and landslide debris. So this table shows you the chronological major flood disaster happened in India and abroad. So with this background, I want to show you the case studies we carried out in our institute by using the machine learning and deep learning technique and climate change impact for the urban areas. The first case study is flood susceptibility mapping for Chennai flood using remote sensing and machine learning technique. So in this study, we consider the entire Chennai basin. Chennai basin means it's along with Adayaru, Kuvam, Kosastalai, and Arniyaru, and some portion of the eastern part of the wetland region. So this study mainly carried out for knowing the comparison of various machine learning technique, how it's effective for urban flood modeling. So the Chennai basin is having a 7,382 square kilometer. The altitude varies from 0 degree to 10 degree. So batch wise, we are having some hillock area, and mostly it's a flat topographic terrain area. It's having lot of wetland, lakes and wetlands. So the coastal flood is very frequent in Chennai basin due to the storm surge and heavy flow from the Adayaru and Kuvam river. So the annual average rainfall of the Chennai basin is around 950 mm. So in this machine learning studies, the basic necessary input data are land use, land cover data, rainfall data, digital elevation model, topographic wetness index, then the topographic ruggedness index, stream power index, slope, curvature, geology, geomorphology, and soil. So this table will tell you what are the data sources and how to prepare the input data set. So the this table will tell you the significant relationship with the input data set and the impact of flood inundation. So if elevation is a direct elevation is a inverse relationship with the flood inundation. If elevation is low, the inundation capacity will be very high. Similarly, the slope is high. It is also a inverse relationship. So slope is high, the inundation will be low, and the very low slope, the inundation will be high. Like that, we have to relate the each and every parameter and its spatial relationship to the flood inundation. So for this study, we prepare the digital elevation model for the Chennai basin. The first picture, you can see the digital elevation model. The elevation level is vary from 0 to 1,337 meter. Then the next picture is the slope. Slope is the first derivative of the elevation. Here the slope is varying from 0 to 77 degree. And similarly, the stream power index will tell you the amount of energy in the stream to penetrate through the particular area. If stream power index is more, the inundation will be less. If stream power index value is low, means it will try to inundate in that particular area. Similarly, curvature is the second derivative from the elevation. So here the curvature values will vary from minus 47 degree to 45. So we can classify the curvature into three classes like flat terrain, convex, and concave. Then topographic wetness index. Topographic wetness index is nothing but the formula wise it is ln of A by tan B. It will tell you the amount of saturation in that particular area. If TWA value is high, means that particular area the topographic wetness index values is very high. That means that particular region the wetness values is very high. So whatever the precipitation is happen in that particular area, immediately it will transform into the surface runoff. If the topographic wetness index value is low, means there will be some amount of recharge and some amount of the remaining excess water will be transformed into the surface runoff. The next factor is the aspect map. Aspect map, directional aspect map. It is derived from the digital elevation model. So it will tell you what are the different type of slope and its corresponding direction. So based on the slope direction, the wetness values will vary. That will induce the different amount of floods. So this picture will tell you the rainfall variation in Chennai basin. So here the rainfall values are, this is prepared from the CHIPS satellite precipitation data. This is a mean annual rainfall value for a historical period. So here the precipitation value is ranging from 860 to 1876 mm. So if you see this one, the coastal region is having more amount of rainfall, then it is gradually reducing to the inner side. And similarly, the drainage distance from stream will tell you how much distance is effectively contribute for the flood disposal. Then next is flow accumulation. Flow accumulation tell you this how much amount of flood will contribute for one particular location from the upstream area. Here you can see the river pattern. The bottommost portion you can see this one is Adyar region. And this is Paliganai wetland, and this will act as a separate watershed in the Chennai basin. And this is the Adyar river. Then this is the Coombe river basin. Then Kosasdalai and Arniyar also you can see in this picture. Then next picture is the land use land cover image of the Chennai basin. So here you can see this settlement area shown in red color. Then the barren land or wasteland will be shown in yellow color. Then agricultural land is shown in green color. Then this is the dark green area is the forest area covered in the Tiruvallur district and hilly region of the Eastern Ghats area. Then water body wise, Chennai is having a lot of lakes and wetlands. That is shown in blue color. So next is the soil map, spatial variation of the soil map in the Chennai basin. Here you can see most of the region covers sandy clayey loam. Some isolated location we are having rocky, loamy sand and clayey loamy sand soil, as well as we are having some clay soil also. Then geomorphology wise, if you see this one, we are having alluvium, coastal plain and dentational hill there. Floodplain, pediplain, structural hill, upland, and water bodies also there. So each and every geomorphology feature will act as directly influencing the flood inundation in that particular area. So normally, if you consider the alluvium area, alluvium region will have more amount of water holding capacity. Whenever there is a precipitation happen in that particular area, immediately it will transform the rainfall into a runoff. Similarly, for the coastal plain region, the precipitation will immediately transform into the runoff area. So in this study, this picture will tell you the overall methodology of the study area. So the first foremost thing is you have to prepare the flood inventory data. This flood inventory data we prepared from the processing of micro satellite data, and we find out the flood inundation happened during the peak time of flood in 2015. So from the 2015 flood inundated data, we collected the sample points. From the sample points, we divided into 70% data for training and 30% data for testing purpose. Then we developed the machine learning model for a random forest support vector mechanism and logistic. Not only for these three model, we prepared some more model. In boosting, we prepared 4 or 5 models. Anyway, I will show you the results. So these input data sets aspect land use, land cover, geology, geomorphology, soil elevation, stream power index, flow accumulation, curvature, slope, topographic wetness index, rainfall, all this layer, whatever we prepared from this thing, we we converted all these things into 30 by 30 meter geotiff file, and the flood inundation point data also converted into 30 by 30 meter pixel, and we prepare all these things in same projection and same cell size. From this, the data is extracted from this each and every layer, and we constructed the data frame for this flood inundation model. After preparing the data frame, we did that variable of influence analysis, because out of this 12 parameter, which parameter is influencing more, which parameter is influencing less, we used the variable influence of parameter analysis. Based on that, we finalized the 12 parameter. Then we used the random forest support vector machine and a logistic regression algorithm for determining the future prediction of flood inundation in that area. So now, how this machine learning is working means it is a subset of the artificial intelligence program. So normally the machine learning will be classified into 2 types. One is supervised learning, and another one is unsupervised learning. The supervised learning further classified into 2 types. One is classification based supervised analysis. Another one is regression based supervised analysis. The unsupervised classification, mostly we are using the cluster based analysis. We are having K-means hierarchical clustering analysis, Gaussian mixer, and neural network based analysis. In regression type, we are using linear, support vector regression, GPR regression, ensemble method, and decision trees. In classification, we are having support vector mechanism, that is a classification algorithm wise. Then Navier Bayes, nearest neighborhood. So many classification algorithms are available nowadays. So in this one, I think the program is started by yesterday onwards. Am I right? Hello.
Yes, sir. Yes,
Yes,
sir.
sir.
So most of the professor they cover the basic and fundamentals of machine learning algorithm. I will give you the glimpse of machine learning algorithm. I don't want to go into that detail. So in this study, we used a random forest analysis. We classified this input parameter into various random trees, and we tuned the parameters for getting a better accuracy. So like that, we prepared the algorithm for support vector regression and logistic regression also. Apart from that, we prepared so many boosting algorithm. We used the ATAL boosting algorithm, gradient boosting, extreme gradient boosting, and various boosting algorithm we tried, and that results also we derived. Then after deriving all these things, we have to do that accuracy assessment. For accuracy assessment, we used ROC curve, AUC and ROC curve. For that, we determined the evaluation matrix. So in the evaluation matrix, we find out the accuracy, sensitivity, specificity, precision, and NPV values. So this will give you the multicollinear analysis and variable of influencing result. So almost all the parameters is required for this analysis. So these results will show you the three model results, that is random, support vector machine, and logistic regression. So by seeing these results, if you see this one normally, support vector machine will give you better results than any other model. Here you can see this one. Along the river courses, the flood inundation will be very high. Then in that Palikarne wetland region, the flood inundation will be very high, shown in that support vector machine model. Almost all the model, that particular region classification was very good. Then in that logistic regression also, it's simulated well compared to the random forest analysis. The area of three different classification method values are shown in this particular table, and its accessibility percentage also shown in this picture. So apart from that, we prepared the gradient boosting, extreme gradient boosting, random forest and Navier bias model results also we prepared. In this one, if you see this Navier bias results, it's not predicted well in that flood inundation analysis. It might be because of that it is purely based on the probabilistic method. So it's try to delineate with 1 and 0 like classification. So the prediction accuracy was very poor in Navier bias, but compared to other model, this gradient boosting, extreme gradient boosting, random forest, elastic regression, and support vector machines are predicting well in that one. So here that in validation wise, we try to fit that ROC curve for the three models. So based on that, if you see this one logistic regression, the ROC value is 0.95. Both the random forest and support vector machine is having the accuracy of 0.3. So prediction wise, it's very good. But here, if you see this one, random forest and support vector machine are having equal amount of ROC values. But the inundation mapping wise, the support vector machine is performing better than the random forest and elastic regression. So these are all the remaining models, area classification area and other things. So the discussion wise, how this each and every parameters are influencing the flood inundation model, which parameters is more important for flood inundation, and how to tune the parameters. So if you see in this results, the geomorphological formations are very important for flood inundation. Then the topography wise, that flood susceptibility is very high for the converse type of slope and a negative curvature. So that will try to spread that flood in that particular area. So here that if you see that results in almost all the model, the northern and the southern Chennai region like Minjur, Valacheri, Gindi, Tamra, that areas are highly vulnerable for flooding. And the coastal region mostly all are having highly vulnerable for flooding in this one. Similarly, for the other parameters like topographic wetness index, topographic ruggedness index, land use land cover change, and normalized differential wetness index, all these things are directly influencing the flood inundation. Okay, so the next, how to validate this flood inundation model means we already collected the 30% flood points. By using that, we can validate our model. So the next study, I will go to the next study. The next study is the effect of climate change and the land use land cover change for the Tamil Nadu coastal region by using the machine learning model. So how far it is different from the previous model means previous model we used the static input parameters, like we are not considering the varying parameters of the land use land cover or the rainfall pattern. So this study, we used the coastal stretch of the entire Tamil Nadu, and we included the climate change parameters because the flood intensity or flood inundation area will vary based on the amount of precipitation and duration of the precipitation amount. So to evaluate that thing, we used the land use land cover changes and correspondingly the climate change for amount of precipitation because of the climate change during that particular period. So we here you can see the 2000 flood inundated area pictures. So the study area is the entire stretch of the coastal stretch of the Tamil Nadu. We took the 100-kilometer stretch from the coastal region. So this is the detailed boundary of the coastal stretch. So for simulating the flood inundation, we consider the additional parameter is height above the nearest drainage line. This is hand data because in coastal region, most of the streams are flat and the elevation difference between the adjacent land to the river bed will be very minimum. So normally this vertical variation may not be identified by the digital elevation model effectively. So that because of this region, we used the direct data set of this hand data for finding out the effective inundation of the flood in the coastal region. That means flat terrain area. So the remaining parameters are similar to the previous studies. So here, what is the new things means we find out the land use land cover change variation for 2030, 2040, and 2050 period by using the machine learning algorithm. We used the random forest algorithm for future prediction of land use land cover changes. Similarly, we collected the climate change data from the CMIP6 data portal. Then we did the initial data processing. We done the bias correction with the observed IMD data set. Then we interpolated the rainfall values for the entire coastal stretch for various scenarios like SSP 1.26, SSP 2.4.5, SSP 3.70, and SSP 5.85 is the extreme scenario. We simulated the rainfall variation for 2050 to 2100. And so based on these two data, in future period, how the flood susceptibility will be there, we done that analysis. So in this study, the additional data is the hand data. Apart from that, the previous 12 data set is considered for analysis. So we done this future impact analysis, that is a variable influence analysis based on the 13 parameter. You can see this picture how the variable of influence is there. So we consider the entire data set for this analysis. So this picture you can see the parameter spatial variation of the each and every parameter. So in this, the first picture will show you the digital elevation model of the particular region. So here the digital elevation model elevation values vary from minus 3.16 meter. This minus negative values means it may be a depression or it may be a quarry. And the highest elevation you can see somewhere in that extreme down south, and you can see in the northern region. Then we find out the slope. Slope is the first derivative of the digital elevation model. It will tell you the change in variation of the elevation between the 2 pixel points. Then we find out the aspect map. So based on the aspect, the flood inundation will be there. The runoff generation will be there. It's a critical parameter. Then we find out the stream power index map. So based on the stream power index, wherever the flat area, the stream power will be low. It will try to inundate the flat. Wherever the stream power values are very high, it will try to breach that area. It will form streams. Then topography wetness index is you can say it's the inverse parameter of the SPA value. So wherever the topographic in wetness index values are more, that area the flood inundation will be very high. Wherever the topographic wetness index values are low, it will have very less chance for flooding. Then drainage density is nothing but within a square kilometer, how many number of rivers, river or streams are present in the particular area. From that, we can find out the density. So this picture will tell you the drainage density value. As per the drainage density, if you see that Kaveri Delta region, we are having more drainage density compared to other region. Then next is land use land cover changes. So this land use land cover changes, we use the Markovian chain method and ANN technique and machine learning algorithm. So first, initially, we have to classify the land use land cover image, satellite image for 2000, 2010 and 2020 period. By using this three period, giving us an input to the machine learning model, we can predict the land use land cover changes variation for the future period. So this variation of land use land cover, it's you can see in your zoomed view, because in this particular view you cannot change clearly how the urbanization happened in the coastal states. But in zoomed view, you can see the changes in the urban area. This is for Chennai and Puducherry region. So based on the land use land cover change, first we have to validate our land use land cover change accuracy. For that, we use the kappa statistics, and based on the kappa statistics value, we use this map as a input data for the future prediction algorithm. For future prediction, use the land change modeler available in the RGS. So by using this 3-period image, we predicted the land use land cover changes for 2030, 2040, and 2050 period. So in this picture, you can see the land use land cover change variation for the 2040, 50, 30, 40, 50 period. So this is validated for 2020 period. From this picture, if you see this one, vegetation variation is slightly changing in the future period, and urbanization value also increasing in the future period. After predicting this land use land cover changes, then we are going to find out the spatial variation of precipitation in the future period. For that, we use the climate change model. We use the CMIP6 data for finding out the future period precipitation data. So after finding out the suitable model, because in climate change model we are having so many data sets, nearly the 27 data sets we used our previous study. So based on that, we identified the EC Earth 3 and the EC Earth 3 wedge data are more suitable for our region. So in this study, we used the one EC Earth 3 data set. Only one data set we considered for our future precipitation variation study. So this data, this climate change data is validated with the IMD gridded rainfall value by using the bias correction. After done that bias correction, that data set is used for our future flood prediction analysis as a input. So this picture will tell you what is the difference of SSP1, SSP2, SSP3, SSP4 and SSP5 scenarios, and similarly RCP 2.6, 4.5 and RCP 8.5. Each scenario depends on the radiative forcing algorithm, how much amount of radiation is emitting, considered by this each and every model. So in this study, if we see, we consider SSP 1.2.6 and a SSP 2.4.5, SSP 3.7 and a SSP 5.8.5 scenario. So based on that, we simulated and we find out the future predicted rainfall for 2020, 30, 40 and 50 period for SSP 1.5, 1.2.6, 2.4.5, 3.7.0 and 5.85, 8.5 scenario. For each and every year, we prepare the rainfall data. So in this picture, you can see the spatial variation of rainfall amount for each and every year. So after that, the next step is preparing the basic input for the machine learning model. So in this data, in this analysis, we consider the geomorphology. So geomorphology data we prepare from from the GSI dataset. So next is preparation of digital elevation model and slope. So in this study, we consider the SRTM 30-meter DEM data. Why we consider the SRTM DEM data means it is having very less voids for the reservoir and backwater region. For other DEM, it will have a void in the rivers and that backwater region. So here you can see the spatial variation of the elevation values. From this, we prepare the slope map. So in this study, the slope values are very well derived from the SRTM model, SRTM dataset. We tried this slope map for other dataset also, but the agreement was not good from the other dataset. So finally, we decided to use the SRTM data. Even Cartoset we tried, it's having very good resolution, but the problem is some of the region wherever the voids are there, that voids are filled once again with the SRTM dataset. So finally we decided the SRTM version 3 data. It is very good data and it's delineated the slope very well, especially in the Kaveri region, flat terrain region also. It derived the slope very fine. Then we derived the aspect data. It's a directional slope values. So here you can see that wherever the flat terrain areas are there, it is well derived or well simulated from the digital elevation model. So the next data set is the stream power index map. So it is derived from the same SRTM DEM. Here you can see this one. The SPA values are very high in the steep slope area, and for the flat terrain area, the SPA values are very low. And similarly, the TWI values, if you see wherever the flat terrain areas are there, that area the TWI values are very high, and steep area the TWI values are very less. That means the flat terrain areas are there means it's having more chance for getting inundation. Then next parameter is the drainage density. So it will tell you how many number of streams are there within that particular area. If drainage densities are more, the chance for inundating in that particular area will be very high, because the streams and the drainages will bring the flood from the upstream area to that particular location. So the particular location will get inundated if the number of streams are more. Similarly, this is the soil distribution map of that coastal region. We are having mostly clay soil, clay loamy soil, and loamy sand soil in isolated locations, and sandy clayey loam. So mostly wherever the clay soils are there, the infiltration capacity will be very low. That area, the vulnerability for flooding will be very high. The next data is the hand data. I already told you the flat terrain area, it is very difficult to identify the elevation difference of the stream as well as the adjacent ground. So this hand data will tell you the stream to adjacent area elevation, how much is there. So if the elevation variation is very low, means that particular areas are very high vulnerable for flood inundation. The red color zone or the hand data values are more, means that areas are having very less chance for inundation. So in this study also we use a random forest algorithm. for the flood inundation mapping. So after using the tuned parameter, after correcting the tuned parameter, we simulated the flood, and the agreement was plotted in a ROC curve. It's showing very good agreement for the flood inundated. So in this picture, if you see this one, we consider the spatial variation of land use land cover data for 2020 and corresponding 2020 precipitation data set, along with the remaining static input parameter for the flood inundation model. Here the dynamic parameter is land use land cover as well as the climate change induced precipitation values. So by seeing this picture, we can understand very easily for each and every year, the rainfall intensity is increasing. So the flood vulnerability also increasing each and every particular point. So especially in the Kaveri region, Kaveri Delta region, the flood vulnerability is increasing gradually. So for each and every scenarios, we done this analysis. So based on the analysis wise, SSP 5.855, the extreme scenario is inducing more amount of flood vulnerability compared to the SSP 4.5 and SSP 3.7. SSP 3.7, the flood inundation level is very low. And if you see this 2.4.5, this is the basic scenario. In this scenario, you can see many places are having green color region. That means the flood vulnerability chance for the future period. By considering the 2.4 scenario, the flood inundation will be very less. In the base period analysis, this one to SSP 2.4.5, there is not much increase in the rainfall. But if you consider the 3.7 and 5.8.5 scenario, the flood inundation vulnerability is increasing drastically. So here you can see number of red color region. So the corresponding area for each and every scenario is plotted in the nearby picture. So based on the picture, if you see the 2050 to 2100 period, the chance of getting inundation will be very high. That means because of the climate change, not only the temperature is increasing, it will induce the more amount of precipitation. That time the urbanization and land use land cover changes also very high because of the urbanization and other activities. So it will induce more amount of flood inundation in the particular region. Okay, from this analysis, we identify the various segment and how much amount of land use land cover changes are happen, and the corresponding influence of flood inundation happen in different segment was analysis in this study. So the next study was carried out for Bangalore urban region, Bangalore metro region. So in this study, we used the MCDM technique, that is TOPSIS technique, for flood inundation assessment. So TOPSIS is nothing but it is a multi-criteria decision analysis, the technique for order preference by similarity to ideal solution. And this is one of the best method for doing the parameter influence and parameter weight determination. So this study also, this study is completely carried out within that urban region of the Bangalore. For identifying this flood inundation model, the input data are similar to the previously shown results. So all the parameters are almost similar, but the difference is each and every pixel wise analysis, we are selecting the pixel randomly. The same analysis can be carried out for the entire pixels, but sometimes the analysis will be very tedious for considering almost all the parameters. So instead of that, we generated the random points within that within that boundary of the study area, and this data set for each and every parameter will be transferred to the Excel for doing the weight determination by using the topsis technique. So the study area, if you consider this is Bangalore urban region, it's having 742 square kilometer, and the elevation ranges is 920 meter. The average annual rainfall is 931 mm. But it's having number of extreme rainfall even nowadays in that recent period. The temperature variation is 18 to 38 degree in summer and 12 to 25 degree in winter. So this picture will tell you how the urbanization happened in Bangalore. This recent period, the blue color region shown here, it is extended drastically. That region was considered in the analysis for doing the flood inundation mapping. So, so in this picture, you can see very clearly how many number of urban water bodies was disappeared due to the urbanization. So many lakes presence in the Bangalore was encroached and get urbanized. Because of this effect, the flood inundation is very severe in Bangalore region. This is similar to our Chennai region also, but Chennai will be inundated by two scenarios. One is tropical rainfall and storm surge happen in that Bay of Bengal region. Another one is encroachment of the natural water bodies and natural drains that will induce more amount of flood inundation in Chennai. That is poor urban drainage management. But in Bangalore, the main reason is urbanization and the disappear of these lakes or encroachment of the urban water bodies. This picture will tell you how the urbanization was happening in that time segment. So between 2017 to 2020, if you see, almost all the areas in the Bangalore urban region was urbanized. So this table will tell you the extreme rainfall happened in that Bangalore region. Recently in 2022 September period, the 131.6 mm rainfall was happening in 1 day period. So it was a huge amount of rainfall. 13.1 centimeter rainfall happened in one fully urbanized area, means it will produce huge amount of flood. So the remaining input data are static GIS input data set. Here we are preparing the input data: land use, rainfall, depth, topographic wetness index, stream power, stream ruggedness index, slope, curvature, geology, geomorphology, soil data. All the input data are prepared from the Bokosh and NBSS LUP data. This is soil survey and land use planning. Their website, we collected the map and we digitized and prepared the soil data set. And we are having a data set for digital soil map downloaded from the FAO source. And similarly, the rainfall variation, we used the CHIPS gridded precipitation product. So all the data sets are converted into 30 meter by 30 meter cell size, and same projection system we maintain. Then this table will tell you the relationship between the input parameter and the flood extent. So in this study, we carried out the multicollinearity analysis or variable of influence for each and every parameter with that flood inundation capacity. Based on that, we used only the selected parameter, not like the Chennai. Here, some of the parameters we eliminated. So based on that, the remaining parameters, we prepare the GIS input. So the picture will tell you the elevation variation of Bangalore city. Here, if you see, there are two river basins flowing in the opposite side. The dark blue color regions are the elevated places. So the slope map is derived from the elevation map. This elevation map is a SRTM 30-meter DEM data. Here you can see the stream power index. So the wherever the stream power index values are high, that area it will try to breach the thing. That means the slope of that particular area is very high. The remaining areas will be very low values. And you can see the curvature map. Curvature map is prepared from the digital elevation map. Here the curvature is classified into concave, flat, and convex. So next you can see the topographic wetness index values. Here the higher topographic wetness index values wherever you are having, that area the inundation capacity will be very high. Remaining area the inundation capacity will be very low. And similarly we are having a parameter distance to stream map. So wherever that area near to the stream will have more chance for inundation, and the far away point or away from that stream location area will have less chance for stream inundation. Then this map will tell you the spatial variation of rainfall. For that particular year 2022, the rainfall variation is 600 mm to 1200 mm. It is derived from the CHIPS data by using the GEE. Then you can see the drainage density map of that Bangalore. The violet color, purple color shows the higher drainage densities values. That means the particular area more number of drainages or water bodies are there. The green color areas are maybe elevated land or less number of streams in that particular area. Then we consider one more additional data, that is imperviousness surface map. So the this imperviousness percentage of map will tell you these areas are open land or the soils are exposed region. This area may be a build-up land or a paved area. So wherever the paved areas are there, the flood generation capacity in that particular area will be very high. That generated flood will be transferred to the other places, and the nearby downslope area will get inundated. So the green color areas are very less. The percentage of imperviousness are very low. So some of the precipitation water will be converted into recharge, and remaining rainfall amount is transformed into runoff. So this picture will tell you the land use land cover map of the Bangalore during the 2022 period. If you see, almost all the areas are urban areas. Some patches we are having vegetation. That means it might be a park or a wetland area. Bangalore was once famous for a number of parks and greenery area. Nowadays, it's almost urbanized everywhere. So this picture will tell you the geology and geomorphology of that particular area. So the rock type wise, the predominant rock type is peninsular gneiss. And geology wise is having pediment and periplane complex. So both will induce more amount of flood. Then the soil distribution wise is hydrological soils C and B. Mostly these two soil will produce more amount of flood. Then after preparing all this data set, we have to prepare the input data for the TOPSIS model. For that, we have to generate the random points within the boundary area. Nearly 15,000 random points were generated for Bangalore urban region for the 14 selected input data set. So this 15,000 random points with the 14 selected input data is transferred into the Excel sheet for determining the rank and weights of the TOPSIS parameter. This picture will explain you how the data was prepared based on the input as well as the output model. These two parameters, SI plus and SI minus, and the flood potential zone, all these things are shown in this picture. So these are all the basic calculation of the Topsys model. First thing, we have to organize all the 14 input parameter values for the 15,000 points. Totally, it will contains the 14 columns. Then next, we have to normalize the input data by using this formula. Once we determine the normalized data, we have to assign the factor of normalized weight. By determining the normalized weights, then we have to calculate the ideal best and ideal worst parameter. That means in that previous table, I told you the relation between the parameters and the flood vulnerability. So which one is having the direct influence of flood vulnerability, that will be considered as a ideal best parameter. Whatever parameters are having inverse relationship with flood generation, that will be considered as a ideal worst factor or ideal worst parameter. So by using that two parameter, we have to determine SI plus and SI minus. These two parameter we have to determine. Then by using these two values, we can calculate the performance score PI by using this parameter SI minus divided by SI plus SI minus. So this is the initial weight determined for the ideal best and ideal worst parameter. So this picture will tell you how we consider the best parameter and worst parameter. We classified all these things and we done the normalized values. Then after determining the normalized parameter, we multiply it with the normalized weight by using these values. So this is the normalized weights. After multiplying this normalized weight, we can determine the parameter like SI plus and SI minus values. One second. So this table will show you the SI plus and SI minus calculation for this 14 parameter. Okay. So this will tell you the determination of SI plus, SI minus and the PA values for each and every 14 parameters. Based on that, the positive SI positive values you can see here, and the SI negative values also you can see in that next picture. Based on these two values, we can find out the flood vulnerability for that particular region. Here, the red color area shown, this zone is very high vulnerability for flood. If you see in the previous picture, this area, you can see a river stream. This could be very well, you can correlate with the topographic wetness index parameter. There you can see a stream from this end and this particular region. So these two areas, we are having number of tanks and water bodies. So with the flat nature, tanks and the soil type wise, clay loamy soil, very less amount of imperviousness, this area induce more amount of flood in that particular region. Then this particular area, because of the imperviousness and the elevated values, whatever the flood is generating in that area, it will be transferred to the other region, or it will be what is that? Because of the drainage condition, it will be transferred to the other places. So these two regions are having very high vulnerability for the flood inundation. So this picture will show you the percentage of changes for each and every classes. So like that, wherever you want to do that flood vulnerability analysis, first thing, you have to prepare the basic necessary input file. Then the second step is which algorithm you want to adopt. Either you want to adopt AHV or Fuzzy or Topsys, VCore or EDAS, whatever model you want to do, you have to prepare the corresponding model algorithm. Then transfer these values to the particular model. The model will calculate the weights. Based on the rank and weights, you can find out the flood inundation for each and every region. Okay, this technique is called the multi-criteria decision analysis method. This is very simple method compared to the machine learning algorithm, because machine learning algorithm, the data volume will be very high. It will take more time and high capacity computer to do that analysis. For the entire Tamil Nadu coastal stretch, for simulating the flood, we required nearly 2 days to simulate one simulation. We done so many simulation for each and every scenarios. So it is very tedious to do such type of analysis. Even we use very high capacity system for doing the machine learning algorithm. But this type of MCDA analysis, even the 32 GB RAM is more sufficient to do this analysis. 50,000 points doesn't matter. It will do very well with that Excel and other software. So the mapping of flood inundation is depends on your requirement, depends on your data extent. So with that, I would like to stop my presentation. If any doubt or any question, you can ask me right now. Professor Gauri?
Yes, sir.
Yes, please.
Dear participants, you can unmute yourself and ask the queries. So in the chat box, we have some questions. Like
Yes. I could not see the chat book.
one participant asked how you select that EC Earth 3 model.
Yeah, we done a climate change analysis for the entire India. We took nearly 29 data set for that analysis. Three of my students, they done the climate change analysis and its impact on stream flow analysis for various basin in India. So one student was done the analysis how the impact of climate change variation in each and every location, because climate change is not constant throughout our country. So region wise climate change is varying. So one student was done that analysis. Another one student was done the analysis which climate change data is more suitable for identifying flood or stream flow analysis. So based on that, we determined the top 5 climate change parameter data more suitable for our Indian condition. So based on that, I already told you the ECF3 wedge and few more models are performing better for Indian region. We validated that results with our observed IMD data set. So based on that, which one is top parameter that ECF3 data set, we directly take for this analysis. Because if I consider the 5 precipitation data, then the result volume will be very high. We cannot interpret anything. We cannot explain how the data set wise influence on each and every climate scenarios. Then it will be very tedious to explain. So because of that, we consider only one data set and various scenarios, how the land use as well as the climate change variation will induce the flood inundation in the future period. That was the intention of the study. So in that ways, in future period, if you consider the 5.8 point scenario, that is the extreme scenario, even in future period, we are having more amount of inundation, chance for getting more amount of inundation. That is the outcome of this study.
Okay. There's another question here, like which rainfall data you have taken, sir, for the future, like average rainfall for the 10 years or the highest rainfall events?
No. Here the data sets are prepared by the CMIP 6 consortium. They are each and every country, they developed their own climate change model data set. That precipitation data sets are there. So that data set is starting from 2014 to 2100. Okay, so in India we are having IMD graded precipitation data. the first up to 2014, we will call it as a historical period. We will validate that period. We will done the bias correction with the observed data. Based on that, the remaining future predicted data, we will use it after done the bias correction. So each and every model will give you a precipitation. It is not the satellite precipitation product. Okay, normally there are a satellite precipitation model data set like CHIPS, TRMM, so many precipitation data sets are there. It is not satellite precipitation data set. It is a climate change predicted data set by using the CMIP6 scenario.
Okay.
I think
I have a question over here. Like for the land use land cover prediction, you used three data sets like 2000, 2010, and 2020, and then you predicted for 2020, and then the prediction for 30, 40, and 50 were also done. Like, is this three data alone sufficient for the prediction process?
Actually, the prediction depends on the so many factors like the stream network slope, urbanization amount, and what are the influencing factor for the urbanization. I didn't show that particular slide what are the additional input data is required for the prediction model, how the land use transformation matrix are prepared.
Okay.
So first thing, by using this three data set, the predicted climate change data along with this supported data set is validated for 2020. From this 2020 and the transition matrix values, we are predicting the land use land cover changes for 2030, 40, and 50 period. It is not only simple linear prediction.
Okay.
So this land cover land change analysis is a very big analysis. The Clark University, they prepared a separate model for predicting the land use changes for future prediction. So based on that algorithm, we done this analysis. So here some of the slides I didn't show how the transition probability matrix was generated, how the transition was happening from one particular class to other classes. Like that I didn't show because I shown only the validation accuracy of 2020. From that I shown the results of 2030, 40, 50.
Okay. Dear participants, is there any other queries over here?
Dear participant, if you have any other question, I am happy to answer.
Yes, sir.
So I seen some 24 chats. I don't know. Is it questions or some other discussions?
Most of them have given it as a very informative and insightful session. Nice session, nice presentation.
About my presentation, opinion
Yes,
about
yes.
my presentation.
There's one
But
question.
you can ask some questions. I will be very happy.
What are the flood susceptibility factors to affect?
Actually, here we done only the flood susceptibility mapping. We are not done any flood risk analysis. Okay, if you want to do the flood risk analysis, you have to prepare two more additional input data. One is building layer map. Another one is infrastructure map. Additionally, with a population map. So if you prepare these three parameters, then you can do the risk analysis. Okay, in that ways you can identify how many number of building cluster or particular area will be affected by high flood vulnerable zone, moderate flood vulnerable zone, low flood vulnerable zone. Then what is the physical vulnerability of population to escape from that particular zone to safer zone. Like that, we can do that risk analysis also. But in this study, we didn't carried out any risk analysis. But for Chennai flood, we done that risk analysis. I didn't show that results.
Okay, sir. Thank you, Professor. Thank you very much for the
Thank you very much.
full session. On behalf of the Department of Civil Engineering, SRM Madurai College for Engineering and Technology, and the organizing team of AICT ATAL-sponsored Faculty Development Program, I extend a heartfelt gratitude to you, sir, for the excellent and enlightening session over here. Your session was very highly informative, and it was really simulating the research quest over the participants, and the depth of knowledge, the clarity of explanation that you have given, the practical insights, everything, whatever you have shared has almost enriched the understanding of the basic things and the real-time applications. So it was a thought-provoking presentation over here, and we are confident that the knowledge gained from your session will be beneficial to our academic and research scholars who are there as a participant. And we sincerely thank you, sir, for sparing your valuable time over here and the expertise that you have shared with us. We look forward to continued academic interaction and guidance from you, sir.
Thank you,
very much.
Professor Gauri.
Thank
Thank you, Professor Krishna Kumar. I am very much happy if the student contact me at any time regarding this ML or DL applications on disaster modeling. Not only this flood, we are working on all disaster applications like landslide modeling, climate change modeling, glacial lake outburst modeling. Almost all the disaster we are working. So whenever you guys need any help, you can contact me at any time. Thank you for the opportunity. Thank you very much.
Thank you, Professor.
Thank you.
Thank you very much. Mr. Kumar, sir, we'll continue the next session now.
Yes, ma'am, we'll continue, ma'am. I think has to join. Is it audible, ma'am?
Yes, sir.
Is my voice audible?
Yes, sir.
Sir,
Good evening, Mr. Krishna Kumar. Yeah.
Good evening, sir.
Good evening, sir.
Good
You're
evening,
most
ma'am.
welcome, sir.
Thank you.
So,
Am I audible, ma'am? I mean, is my voice audible?
Yes, sir,
Yes,
you're
sir.
audible.
Yes. Okay, fine.
So, dear participants, we are about to start the next session, session 4. So, I would like to welcome architect S. Babjee, sir, proprietor of Vernacular Building Solutions Private Limited. So, to introduce him, he has did his BR from Dr. MGR University, Chennai in the year of 2004 and MArch in Anna University in the year of 2006. And he has a vast working experience and some of the renowned experiences in L&T Ahmedabad and Akindo developers. And he has worked in many, some of his best, very known projects here. That is, landscaping in Vallur Kotam was done by him, and Skywalk Bridge construction phase 1 and 2 at Adayar is being done by sir. And new fish market design at Patinapakkam, multi-level sports playground at Pamal, and many more projects being done under his guidance. And also here he is to deliver a lecture on AI integration for strengthening urban resilience and strategic planning. I hope this session will cover the aspects related to architecture. And he is ready to show some of his real-time projects with us. So I would like to welcome on behalf of SRM Madurai, sir. We are ready, eagerly waiting for your presentations. Thank you, sir. Over to you, sir.
Thank you. Thank you so much. Thanks, Krishna Kumar. Thank you, ma'am. I hope I'm audible because I'm in makeshift arrangement where I'm actually traveling. Hope my voice is audible. That's what's
Yes,
more
sir.
important for me.
Yes,
Yeah,
sir.
fine. That's first thing. And thanks for introducing me, as well as giving an opportunity to explain about the projects which you have done, and where we have also made use of this AI information as well as data-driven design for most of our projects. To give a basic gist about how we are doing many of the projects, I am basically an empaneled architect with Chennai, Greater Chennai Corporation, as well as with CMD, etc., Chennai Metropolitan Development Authority. And we have also been empaneled with many other municipal corporations in India, like Guwahati Municipal Corporation, as well as Vijayawada, as well as right now we are doing some projects with Coimbatore also. So that is one of the key factors, like how we actually ended up in doing mega scale projects rather than doing small residences and stuff like that. So this is how we actually started our office as such. And initially, my first projects were beautification of Marina Beach under the guidance of a landscape architect K. Raghuraman. And even Semmudi Punga was designed by me, along with architect Rupmati Anand, the one who's actually designed Semmudi Punga in Coimbatore today. She's the architect for that. So this is the basic background and how I actually got connected with many of the government-based projects. So this is the principal idea. And I just think if I can switch off the camera, will it be fine, sir? I mean, because is it okay so that I can share my screen?
Yes, yes, sir. Yes, sir.
Huh?
Okay,
Yeah,
okay. You can
I'll do that.
just share your screen, sir.
Yeah, definitely. So I'm just straight away going into the presentation. And this is quite a very peculiar because I'm mostly used to witnessing all the students who are participating in the program, but doing it online without knowing who is there, it's quite a tricky thing. But still, I just want to make everyone understandable about what exactly our projects are. So I have given this presentation for mostly to the architecture students and as well as the faculties. But this time I'm thinking we are giving it for a civil based faculties. So to start with, what is our understanding about artificial intelligence and how it is exactly connected with our architecture program is most of the times architects take up this process of designing because I mean, if it is architecture is always about designing buildings and designing campuses and designing cities and stuff like that. And in our case, we felt designing was all fine because we have been always taught about how to uh, design spaces like residences, colleges, and many other such stuff. But when it came to city scale projects, the number of parameters which is involved in taking a decision was very, very critical because it is not my personal whims and fancies about the design. It is about what exactly is required by the entire public in general. So we actually initial days, most of the designs were very personal. We took a decision based on whatever we thought is correct, and we didn't actually give much consideration to the public in general because most of the information which is given in NBC as per the norms, that is what we've generally followed. But later, as we kept moving and as we started working with public projects, we found there was one small parameter which was always negating our design. I think that was the initial hitch which we got because they were actually using the project, but still they were not very happy with the project. So they slowly started to do something else rather than what it was intended to. I think that is very, very critical when we had to do a design in a urban scale project. So coming back to the major things which has been told is climate, cities always face climate, infrastructure, and social challenges and stuff like that. What we personally felt is this is all there, though it looks like doomsday, but I don't think it's doomsday. There are a lot of factors actually happening, but when it is visible, when it is really when we are able to really see that then exactly we get really annoyed and we get petrified, because Delhi is one nice example where you get the uh, just a minute, sir, just a minute. Krishna sir, I'll just join in 2 minutes. Sir. Just a minute. Huh?
Oh, fine, sir. No problem.
Yeah, yeah. Sir, yes, sir, I'm resuming. I'm actually in a travel, so that's the reason. That's okay. So I can continue, sir? Krishna sir?
Yes, sir. So you're audible, sir. You
Yes,
can
sir.
proceed.
Yeah. So coming back to this perspective about this information as well as the urban resilience, when exactly we felt there is a primary requirement as an architect is when we felt like we were always guessing the game when it comes to design. It's no more like data driven. I think that was our principal information which we felt we should like. We cannot do the design like how we used to do or how our college faculty taught us. So that is exactly the time we started like hunting down like where exactly we can get consultants who can work on all these parameters. So the first project which we got, or rather like I mean like hello. Yeah. So when we talk about this urban resilience and strategic planning, we have actually given like what all projects we have done, and based on those things we have like understood uh, certain key factors. And though these terminologies like city is actually growing, population is exploding, lot of pollution and other stuff, these are all like typically which has been learned or like studied from school days, because these are all basic parameters which we all know, but still we don't have any kind of a data to like really feel the factor, you know like it has to be like extreme condition where, I mean, if you have to be in Delhi, you can actually feel that extreme smog effect to really choke your breathing. Whereas in Chennai kind of a place, it may not be looking so disastrous, but during the evening times in traffic, yes, it does make us feel like, choked. So we found like, many of the data which is like not actually helping us is because like we don't have proper data for this one. So especially projects which are very huge, say for example 50 acres, 60 acres, despite its magnanimity, that is also compounded in the sense we have a clear earmarked area. Whereas, it's not as it is like how we saw in the previous session, because previous session was like having huge hectares of land, which has got a different kind of a terrain, which has got a different kind of a boundary system. A lot of ecosystems are there, but the projects which architects generally deal is max 15 to 20 acres, 30 acres, or even close to 100 acres also. But still, it is defined by a boundary. So, however, we take all the data which is like available in the open source, but the data cannot be applied especially for this particular project because most of the land in the geotechnical area, if you notice, it will be telling it is a loamy soil or clay soil or whatever, red soil, all this stuff. But in reality, that particular site might be a filled up area. So we always found all this data which is available in general terms are not really applicable for our small site. And most of the times, like architects, we fail exclusively only when it comes to localized information, because we are always we don't have time, and we have always been told the design should be done yesterday, and uh, and we are also running short of details to be done, and it is becoming so engrossed with getting information from Pinterest, and the clients are also very much equipped with a lot of these imageries, so they expect lot from us which is not in reality. So we are tied up in between, where we are like stuck between the data and the response which has to be given for the data, as well as with the imagery which the client is expecting. So this a quasi kind of a location where we don't know where to like really strike a balance is the age-old riddle which architects have been trying to find out. But I'm very happy now today we have this AI information which is helping to advocate our issues or the site issues and our decision making skills to the client also. So that is exactly how we felt we are going towards this urban resilience. So as you can see, the key factors in the urban resilience is, if my screen is kind of rotating, please let me know, or is it
No, sir,
okay?
it's correct. It's proper one. It's correct.
Okay, fine. So, so the climate adaptation and risk management is something which is right now happening, and like where we have to handle the floods and heat waves and stuff like that. And though these are all like very macro level information which is available, but if you have noticed in our projects, these are all very micro level things. Sometimes it doesn't even happen. We don't even have any floods or anything. So most of the times, how the entire fabric of the city functions, that actually determines our property. So I just want to give you examples based on each and every point, and infrastructure and service reliability in wherein we have to ensure the transportation, other services which is under stress, and social and community resilience is one more important in context of urban resilience, and flexible land use and strategic planning using data and AI to plan adaptable multifunctional urban spaces. So, and regarding the strategic planning, we feel population growth is a very important thing, mobility as well as land use and disaster risk preparedness. You will not believe there are various projects where in which we have not considered any of these points just because we didn't get data. Because it's these data which we are talking about, especially like disaster risk preparedness. If you have to talk about a disaster risk preparedness for a area in Chennai, say for example in Katipara Junction, which is only about 2 acres of a site which I have got, and how exactly we can work it out. This data is not available at all. So we have to do a basic questionnaire, and we have to give more information to all these AI related tools, so that we get some kind of a simulation which is helpful for us to take a decision, a detailed design decision. So most of the times where we are really stuck, or where we are exactly feeling handicapped is Chennai, though it is a cosmopolitan or a metropolitan city, we are very badly having a lacuna in terms of data. In terms of like the general data is available, but if you have to be like more specific about what is the volume of traffic which is happening on Periyar Road, what is the volume of traffic which is happening on Nelson Manikam Road, we don't have a clue about it. And we have to have deploy people, consultants, to get the data done, and then we have to run a simulation and find the answer for it. That's how most of the projects are done. So I will directly jump into projects where exactly we found these have been addressed in the right way, despite. And the beauty about entire design is the general public may not know what exactly we have designed it for, but in long run, in a long term, we have actually considered all these points into consideration while designing itself. So that's how these projects have been done. So if I have to tell you about what all has happened is, we have done projects. These are the project lists which are shown here. People who are very familiar with Chennai, they might be knowing all these places. And I just want to tell you about, there's a place called Madipunga. It is a historically very old space where it was when British was there in India, especially in Chennai. The Chennai's entire region was divided into two areas. One was the black town and one was the white town. And the white town was walled with a huge wall, and that wall was constructed using the tax money of the people. So that is how the name Wall Tax Road comes. And the entire wall was removed except leaving one particular portion, and that portion is known as Madipunga in Chennai. It has got two different levels of gardens. And another area which is there in Vallur Kotam, which everyone must be knowing, Vallur Kotam beautification, we only did it. Similarly, there are a lot of flyovers which is happening in Chennai, where Vadapalani flyover, as well as the Villivakam flyover, and such flyovers which are pretty huge actually. We have done the landscaping for the flyovers, and there are a lot of OSR parks which we have done for Chennai Tamil Nadu Housing Board, as well as for Chennai Metropolitan Development Authority. Recently, this Ayappantangal bus terminus has been designed by us. Work is happening, and there's a huge fish market which is there in Loop Road, bang opposite to Marina Beach. That is one of the iconic projects we have done. And there's a similar market which is happening in Patinathar, which is in Trivitriur. And there are a lot of streetscaping which has been done by us for Sipcot Industries. And that is the one which is there in Navalur, Siriseri. And we had done recently, CM Stalin had opened a flyover for us, which is happening in Tolkapir Park. It's a footover bridge which we have designed recently. And we have done even a park, which is a neighborhood park, which is happening in KK Nagar Shivan Park. So if you have noticed, we have actually taken care of most of the primary components we have taken into account to understand how this AA integration matrix can be worked out, to work out on the smart zoning, to work out on mobility forecasting, land use optimization, climate risk and flood and other things. So basically, these are the various tools which we use. Certain tools, certain AI tools are like open and open market, it is available. Certain tools are it has to be paid. Certain tools have a perpetual uh, uh, you know uh, license for it. And most of the times, we do have other consultants who actually does it for us, because we are more concerned about how do we take a decision based on a data, rather than even cracking on the data itself. Because that's how I think we architects, we want to move forward in this new future, because we don't want to eat everything. We want to collaborate with many people. So we do have various environmental engineers in our board, like Dr. Vijay Lakshmi is one such person, and we have a lot many other multidisciplinary consultants who actually help us in figuring out what is the traffic analysis, what is the material specification to be used. So one such company is called Tarusium, which is also more into heat resilience, and they are more into that kind of consultancy for us. So coming back to this Madipunga project, so this is exactly the project spec. You can see which is like there on Old Jail Road. If I mean, this can be understood by people who know about Chennai because most of my projects are in Chennai and a few in Coimbatore and as well as in Vijayawada. But right now, I'm showcasing only projects which are from Chennai. This Madipunga project is a historical value. It's got two levels of gardens, which was a very dilapidated stage. But later we had to like intervene and understand. We have to do a because this property is also by ASI, Archaeological Survey of India. So lately, like then they had to come on board, get the structural corrections and the structural rectifications. Later, we came in with the design of the walkways inside and the landscape inside. So these were the initial sketches. Like every project, as an architect, we do initial sketches to adhere to the human-centric design. More than anything, like the first user is the human. So we design everything perspective with the human-centric movement, and then we actually figure out what are the ergonomic applications which we can do for the particular location. Then it becomes like what are the other information which we can load into this particular design. So in this particular design, we took about the climate risk and flood prediction because terrace gardens were like the most important thing where you can retain the water retention as well as we can slow down the runoff. So this was the intention behind this project. So if it had been just another project, we would have simply done some kind of a lawn here and there. And you can see the pictures which you are seeing at the bottom are all real-time pictures. So if you notice, we could have simply done a paver block without any much of a percolation. But this is the kind of paver block we have done so that water percolation is like, taken care of. And by doing this one, like, the grass also grows, which also like, helps us to like reduce the urban heat island. And we have not cut any trees inside this particular project so that we worked out the planter boxes around the existing trees. So if you notice, like, this is exactly what we have done based on the data available, as well as how we want to like integrate this data for design decision making. So if you see in the initial sketches, these sketches were like, initially done for our purpose, but in the sense like to present it to the client and everything like that. But that later on, what happened is we had to do with the real time situation how exactly the planting has to be done, how exactly the material has to be chosen. So these were the primary criterion for us to take a decision for this particular project. So terraces are urban flood management tools and not just gardens. So this is very peculiar about this project is in an urban setting, we generally find only parks which are like, very planar or very literally very low lying and doesn't have much of a datum. Whereas this particular project was available in two different levels. It was like a terrace kind of a thing. And we genuinely enjoyed doing the design of this particular project because it also encompassed the urban heat island information as well as the flood mitigation kind of information. So that was the biggest advantages for us in this particular project. So this was about Madipunga, and I'm going to take a small break, just a minute. Uh, Krishna sir, just 1 minute.
Sure, sir.
Yeah, please. Yes, sir. Krishnamurthy, sir. I'm back.
Sir. Yes, sir.
Sorry. Sir, I'm sorry. I mean, it's a kind of discontinuous, but I had no other go. Now I'm in a much more better location to sit and talk. Yeah. So I think this Madibunga was like one such project where we had a different kind of an experience. But now the one which I'm going to show is Vallur Kotam. I mean, Vallur Kotam is quite famous. Everyone knows about this project because it is in the heart of Chennai city. But not many of them know, like, what exactly we could do as an urban architect for this project is. So this entire project was so botched up in the day one. Like, you would be very surprised to see, like, everywhere inside the property itself, they had road and a tarmac road, which was like giving no pervious, infiltration or percolation of this water. So what we the first decision which we took is like, we will not have any kind of a bitumen surface. So we thought like, this is though it is very simple, but this made a huge impact because the entire property site was like around uh, almost close to like 4.5 acres or like something like that. And the entire area became a huge percolation pit, sir. That is the main, interesting point about this project. So we had a choice of simply having trees and plantations and stuff like that. But we chose not to go for it because the architecture of the project was so very traditional, very Dravidian style of architecture. So we didn't want to hide the architecture with our plantation, so that like we created a very small dwarf growing indigenous species, which is only which is very water resilient. That was the most important idea. So we went for very simple species, but we didn't want to make it like as if it is kept like a simple garden. So if you have noticed that, I think someone is okay. Yeah. So if you notice, there's a nice pattern on the flooring pattern. So if I just run through the next slide, this is exactly what we did as the flooring pattern, and we chose all the species which can grow only maximum 1 feet high. So at any point of day and at any point of time, we actually have this design always available. So this is the entire garden design which we did for the entire perimeter of the project, and this has been appreciated very nicely. And one thing which I want to tell about this project is like where we actually got this inspiration is from in Jaipur. There's a fort called Ajmer Fort in Jaipur, Ajmer Fort, just bang opposite to the Sheesh Mahal, which is there. They would have done a similar kind of a parterre. It's in landscape terms, it is known as parterre. So this parterre has been done exactly in Ajmer Fort. So that was more of a Mughal style kind of an architecture or a Mughal style of landscape, whereas we chose like we will go for more of a Dravidian, more straight lines. And one more inspiration for this particular thing is our traditional column. Right now, after Margari column and everything, you would have all been seeing lot of reels which a lot of having column. So this is the floral column which we did in front of Vallur Kotam main building. So this was really appreciated. It's got a very nice lights and other information. Like it's got a night show with the dancing lights and water fountains and things like that. But overall, if you see it, this project might look as if it is only showcasing plantation in that way. But what we have done is like we have done a growth. The urban heat island has been reduced, and the kind of activities which is happening in this particular site, you will be surprised to notice. I will just show the next slide, which will be having so much of crowd. You can see a look at it. This is not AI generated. I mean, like it is really lot more people are there in this particular because there is a, if you notice, there is a if I can see, there's a chariot. This is a typical temple chariot, which is done out of stone. So you can see even the a gallery where people can sit over here and watch the light show. So this is the kind of uh, outing space which has been given to these people, and everyone really enjoyed this one. And the place which was very derelict in those days, I'm talking about a year back, it was a very sad state of the in city center. Now, right now, this place is sprawling with a lot of people for every weekday as well as weekends, and they have got a beautiful gallery where all the photographs and paintings of Thiruvalluvar as well as Tirukural has been done there. But what we personally felt about particularly this project is we want to increase the water percolation is first point. And the second point, so what I'm trying to say in most of the project is most of the times architects have been seen only as, or architects or landscape architects have been seen only as people who do like outward work in terms of maintaining the, paint work or like how aesthetically it is done. But there are a lot of engineering behind it, which actually makes us feel more connected to the project because that is the only grounding thing which makes us more uh, convinced about this project than the aesthetic perspective. So we felt how best we can give the engineering entities without making it very what do you call, like normal, but more aesthetically pleasingly presenting it. That was our initial intention. So this is the beautification project of Padi flyover and Vadapani flyover. Over here also, if you notice, this is exactly what we have done. We have made these people to use this place, and we have made it very vibrant with a lot of paintings and other things. But end of the day, we only look at only these factors. But the main important factors, which is, this is the overall site plan. Uh, but the major important thing is they are the first and foremost thing which can reduce on the dust pollution, and they also actually work out as a very interesting residual spaces when you have to find out the land use optimization. The residual spaces, they get converted into green infrastructure, and people started using these park more than the regular park. This has become much more interesting for them. So we always find our projects are almost touching on all the urban resilience points in a very nice way, wherein we also get a feedback from the general people who are using it, as well as we are also seeing it in reality also, because these all projects are all like very much close to our office also, and in very close proximity where we day-to-day activity we actually hit upon these places. So we found like all these functional spaces are very interesting, and there is a OSR. OSR is an Open Space Reservation Park for a Tamil Nadu Housing Board, which is there in Virugambakam. This is a nice project. Now, this project, they asked us only very simple thing is like they wanted a park as well as a shuttle court, indoor shuttle court, and it all started just like a basic design of a park. But later we understood such a huge potential for a place of like almost close to 1 acre or something, more, almost close to half a acre, if I'm not wrong, half a acre. But this was not perceived as a very interesting uh, 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 component which can reduce down on the urban heat island produced with the apartments which is around it. So we took it that into context, and we designed a nice walkway around it. We gave them gallery spaces and made it more of a green space. And we converted all these open spaces into functional spaces where they can conduct some programs and event spaces. And this is the shuttle court which is right now done, and lot the park area is still yet to get completed. So these were the primary information which we kind of collected and how best we could do it for the project. And so this is about the parks and like how it can actually like build the community and improve the air quality and stuff like that. The work is actually happening right now. So once the work is completed, we'll take you some, I will share you some more photos. So this is the bus terminus which is happening, Hypantangal bus terminus which is still which is a very predominant bus terminus because it is also clubbed with the CMRL metro station is also coming. So it's a multimodal hub kind of a location this place is. So how exactly we found out, this whole project is very, very critical because there are lot many stakeholders than we thought actually. So it was not only from the bus term, I mean, like Madras or the Chennai Transportation, the MTC they call Metropolitan Transport Corporation. Not only the MTC, it is also Kumta. Kumta is the central, unit where they run all the metro, all the transit hubs and everything. They are the one single point control where they can get all the maps and overlay everything. So they know everything about this particular project. So they also gave us maps. It also was dealt with the GCC, that is the Greater Chennai Corporation. So they were actually coming up with telling where exactly stormwater flood, stormwater drains have been connected, and where exactly the lowest point is, and many things, such things like that. So the number of stakeholders kept on increasing in such kind of projects. I think this is somewhere like, as an architect, we have to give the real information when it comes to like, urban scale projects. So we have done a nice bus terminus as well as a bus shelter, but taking into all the traffic analysis, taking into all the people movement, and we also had to work out because on the flood, rainwater and other things. So we had a very interesting thing now. This is exactly the situation. Work is happening. The commercial block is almost constructed by this year, June, some mid or something. This project will be completed. So we had to do a real-time analysis about the crowd and disaster simulation. So we actually employed one consultant where we almost spent almost 2 weeks to figure out what are all the data is needed to figure out how the people movement is, how the bus movement is there, and where exactly flash points are happening, whether the bus turning radius is like hitting with the public, and what are the blind spots inside the project. So after finding out all these things only, we have actually come up with this particular plan. So whatever we see in this particular design is not done because of our whims and fancies. It is based on the data which we got from the surveys which we did. And this is exactly the response or the design response we are given to this particular project. So this is a very prestigious project with the office right now. And a lot of work is happening on this one. So once this project is complete, it will become a very important nodal point on this highway. This is a Porur highway. This one is, and we are doing another project which is happening in Thiruvettur Pattinathar market. And even in this project, it is a makeshift arrangement which was there initially, where people had like daily market, but and all the elevation which you're seeing today is not how it is right now because it is all a very old building, dilapidated. So we are actually doing only skin treatment for this entire project, wherein we give a new breath of or a new fresh air, where we can actually see the project in new eyes. Whereas we actually advocated for this project not to be totally demolished. Why? Because you don't know how government bodies function. Most of the times they always come up with the proposal of demolishing everything which is there and then come to with a new project so that the budget is taken care of. But it is our responsibility as architects to talk to them about why it should not be demolished fully and how we can actually integrate the old buildings, and then we can give a new facelift to the project in such a way that budget is also constrained, and we can also give a very nice elevation to the particular project. So that is how this project was done. And today this project has taken up a very nice shape where around 300 plus shops are there in this one. Grocery, vegetable market, fish cutting market, fish market is there. Even small flower market, everything is there in this one. But this is more of a daily market where people bring material on a daily basis and sell it out there. And this is the biggest neighborhood market for this entire area. So today, this is so if the images which you see is all only outward information, because all the shops which was there, that has been retained, and we only constructed the shell so that we gave a facelift to the roof, as well as if you can see a lot of MS framework happening. So this is what the design detailing we have done, so that we don't actually want to totally dose off the entire building. So we have given few corrections here and there by adding few MS work and like few fascia work, so that we could understand like this is exactly what they want about this particular project. So uh, the land was very low lying. We have to increase the land. the height, the level had to be increased, and we had to like do a simulation where exactly people will come and like buy purchase it and how it will be happening. So all these things were done, but we couldn't do it just like that. So we actually had a stakeholder meeting with everyone over there. We had an enumeration where we made sure like everyone's Aadhaar card was noted down, and we made sure like only these many people will actually run the shop, and the rest of the people will not get license to run the shop. So there are a lot of layers which are happening. So, but why am I telling all these things is because as architects generally, we are never exposed, or generally if I'm designing a residence or just a hotel or anything, we are never exposed to the user at all. But in the public forum and the public projects, user becomes the king of the project. So they will actually guide us and they will tell us what to be done. And this is how the entire community benefits out of it. And they actually run the project rather than me designing the project. We become more, we as designers become more convincing to the client, that is the user. Then only this project becomes alive. Otherwise, people can simply check it out, or they can make the project, nullified. So another neighborhood park which we are doing in KK Nagar is Shivan Park, which is also a more of a retrofitting kind of a project, because the trees were all like 30, 40 years old, a large canopy trees. And there was also, this was the overall master plan of that one. So we can see the park is divided on two segments, and the oval central portion is the temple of Shivan. Shivan temple is there, and that's the name how it got Shivan Park. So we basically did a very simple design without much of alteration, but we simply made it more tactile oriented so that people can walk, the visually impaired people can walk without any kind of a disturbance. And similarly, we want to make least level difference, because this area is like surrounded with lots of old people, with a lot of pensioners were there. So we didn't want to have different levels at all. So we will see once we get into this park, the entire park was at one level, but at the same time, none of the area will be flooded during the rainy time. So we gave these kind of tactile flooring. We made like pebble pathways, and we have made many such improvisations within this property. And this is also going to get inaugurated by June mid or something like that. So this is one such interesting park. And this is the fish market, which was telling, which is bang opposite to Marina Beach. And this is the first of its kind when we, it's the first of its kind when we started this project, because uh, it was done in such a way that like it had to comply with the CRZ norms, coastal regulation zone norms. You cannot construct anything permanent over there. So the nature of the project should be temporary, but at the same time, like it has to give a permanent solution to the fish market people. So we went with a huge truss frame structure with the tensile roof and many things like that, with all the state of the art facilities given to them. And today it is like a very interesting project. This is how exactly it looks today. So people are using it in full. This is our first commissioned project, and we are very happy about it. And we won awards for this project also. So even in this particular project, we had done crowd simulation, how people will come, how they will walk, and what kind of a traffic mobility has to be done. So this is how we made this project. And we generally make sure like all the projects, all my public projects will have a toilet which will have two side entries. That is like one is from the main road and one is from the within the property. So these were the key points. And this is one more road project which we are doing in Sipcot Sirseri, which is actually uh, in the process of getting constructed. So this is a huge lake we are doing in this project, where we are like connecting all the water to flow into the lake, and we are regenerating this entire water, lake body. So this was the temporary. This is the footover bridge which we are talking about, which is in MRC Nagar in Chennai. So connecting the Tolkapir Punga, both the east and the west side of the Tolkapir Punga, and this project is like very prestigious to us, and we are it's a suspension bridge which we worked along with IIT professors in Madras. So we had to make use of the crowd simulation software to figure out what kind of material to be done for the flooring and what kind of design width should be worked out. So you can see in this one, CM Stalin had actually inaugurated this particular project for us, and that's how we actually came up with this project. So coming to the conclusion part of it, our design is more data driven than the traditional design. Why? Because we don't want to keep doing this guessing game. Because most of the times the guessing game is controlled by a senior person in an office. But today we want to make the Gen Z and the Alpha, Beta, whatever you want to call them. They also need to understand how to do the design. So we want to make the design more, connected with data, more data driven than experience driven. I think most of the times, like we are always pushed to take a decision based on experience. I think that is no more the case, or that is no more the uh, norm in the future. That's what I personally feel. And I think that is exactly how AA has come into our existence. And I feel which is very interesting for us. And I'm very happy for all the consultants who had actually given us these kind of data for us to take a very informed decision when it comes to design. So I think with that, I would like to conclude it. Hope Krishna Kumar sir,
Sir, yes, sir. So participants who wish to ask any question can kindly ask. Sir, how about this tools, BIM building information modeling tools? How far it is helping you, sir? In
sir, BIM tools are helping us in a very nice way. Why? Because in a nice way, because the first point is we get uh, information with respect to what is being what is the data, what is the data which is being fed into this entire system, because it all works with the data given into this one. So the simulation becomes much more easy, because this is one such software which allows us to transfer between other softwares also. So the BIM data is very much useful for us to export it to other softwares. So that way we are very comfortable with the BIM. So I think that is what exactly I would like to tell, sir, with respect to the BIM software.
any participants, if you have any questions, you can ask. Actually, the resource person is from architecture background. I hope you have seen that. If you have any questions related to architecture also, you can ask. I think there is no questions. Sir, really, it's a very wonderful session, sir. And I would like to thank you for accepting this FDP proposal, being a resource person. Even in your busy time, you have spared your time for us. And I have, you really, I am seeing a very wonderful work. Whatever you're doing is, it's very remarkable, sir. And at this occasion, I would like to thank you very much for your presentation. And on behalf of SRM Madurai Civil Department as well as the organizing committee, we would like to thank sir for giving such a wonderful presentation to us. So thank you so much, sir.
Thank you, sir. Thank you so much. I'm, and I'm kind of running between many things, but still I'm very, very thankful for SRM Madurai. And yes, sir, that's it. Thank you, sir.
Thank you, sir. Thank you for giving your valuable time in between your busy schedule, sir.
Thank you, ma'am. Thank you.
Thank you, sir.
Yeah, the participants, please complete the feedback form for session 4. So this link will be available and we'll not close the meeting till 9 o'clock so that you can find the feedback form